Hi everyone, today's lesson is about Venn diagram once again. We're looking at some harder questions to do with this concept, and we're starting off with question 8. So 80 families in Leeton were surveyed on whether they had a dog or a cat as a pet. 12 families had no pets, 35 had a dog, and 47 had a cat. So first things first, we should actually draw up a Venn diagram, which is what I've done here. Now, the two categories are dogs and cats. And the first thing I suggest that you should always put on the Venn diagram first is what's in the center, if possible, or what's on the outside, which means people or families without a dog or a cat. So the information that satisfies that requirement would be this. Okay, so 12 families had no pets. We're going to write that right outside. Okay, I'm just going to write that in purple right there. Now, the next thing we should do is try to aim towards the middle if we can. There's no information here that actually tells you what's in the middle. But what we can calculate first of all is that all of this, okay, so this number here, this number here, this number here, this number here, whatever it may be, have to add up to 80. So if I get 80 subtracted by 12, that is 68. So these three numbers here should add up to be 68, okay? Now, let's have a read of this part. It said here that 35 families had a dog, okay? What does that actually mean? This includes people who might have a cat as well. So this includes everything within this circle, okay? So not to be confused with people with only a dog, which means no cat. 35 resembles everything here. So I'm just going to color that in just so I can show you what this represents, okay? Now, after I color that in, let's have a look at the next bit. I've got the 47 families who have a cat. Now, that resembles this part of the circle. Now, have a look at what I'm shading in because I've shaded in something that overlaps, which is the center between them. So I've counted this part, which is the number of people who have both dog and a cat twice, okay? Because these people include people who have a cat, and these people also include families that have a dog as well. So I've counted them twice. If I add the 35, which belongs to this green circle, and 47, which adds up to be whatever this is in this circle, okay? 35 plus 47 is equal to 82, okay? So remember, I've overcounted, right? Okay, I've overcounted by this amount here, okay? And the number that I should get in total, if I count everything just once, is 68 families. So have a look at the difference between 82 and 68, okay? If I get 82 minus 68, I will get 14, and that resembles this part of the Venn diagram. So I'm going to rub that out, and I'll put 14 there. And once I have that 14 there, well, now I can complete the rest. So remember, 35 families had a dog, okay? Which means people who only just have a dog would be 35 minus 14, which is the number 21. And in this circle, we know that 47 families had a cat. So 47 minus 14 gives me families who only just have a cat, and that would equal to 33. Okay? So if we add all these numbers up, they should total up to become 80 families now. Now that the hard work's done, we can now go through question B. How many families had a dog and a cat? So the word "and" represents the figures or families who have both of them. And this is indicated by the center number, which is number 14. So our answer for that is just 14, right? How many families had a dog but not a cat? So people who had a dog includes these numbers here, but if they don't include people who have a cat, then remove that number, which means only 21 families. Okay, satisfy this requirement. And how many families had at least a dog or a cat? Which means we can have a dog or a cat or both. So if we total up these three numbers, that will give us 68. Now, what if I asked how many families had a dog or a cat, but not both? So a dog or a cat represents these three numbers. But if it's not both of them, then we don't include this. So that means we only include these two numbers, which totals up to be the number 54. Now, I want you to be observant and have a look at this question. This question is all about just how many families had this and that, okay? It doesn't actually relate to probability. And where students actually fail to complete this in exam is they're too used to finding probability and they'll write 14 out of something. So just make sure you read what's asked there. Because if you have a look at the next question now, it says find the decimal probability. So finding something out of something now of selecting a family with a dog only. So a dog only represents 21. And that 21 has to be out of 80, right? Because there's 80 pets. But we're looking at a decimal probability. So if I put that on my calculator, I do get 0.2625. Now, if they asked either a dog or a cat, but not both, okay, it means that it's these numbers here, but not this one here. So that will be 54 out of 80. And if I type that on my calculator, I do get 0.675. Okay. And then for part 3, at most one pet. Okay. So what does this actually mean? If it's at most one pet, that means we can't have two, but can we have none of them? We can have none of them, okay? So this does include people or families who don't have pets because we want a maximum of one pet per family. So no pets and one pet counts. So these three numbers, they add up to become 66, and we can do that by adding these three if you want, or 80 minus that number. So the answer to this is 66 out of 80 as a fraction, but 66 out of 80 is 0.825. Now we look at part 4, which is asking for at least one pet. So at least one pet means either people who have a dog only or a cat only, or both of them. So these three have to add up to become 68. So that's 68 out of 80, which does become 0.85 as a decimal. Okay. Part D says, given that a family has a pet, what is the probability that they have a cat? So this is a concept on conditional probability. So the condition is we have a family that have a pet. So that excludes the people who don't have pets. So when you're looking at these numbers here, but these numbers in total would be the number 68. So our answer here has to be out of 68 instead of the 80 that we usually find. And how many of those have a cat? Now it doesn't say only have a cat, it says have a cat, which means that it doesn't matter if they have a dog or not. So let's include the people who have dogs as well. So we have 14 plus 33, which is going to become 47. So the answer is going to be 47 out of 68. And this time we're not finding a decimal probability, it is just the probability. Okay, I hope that helps you with question 8. We're now going to look at question 9. So question 9 is a little harder. At Mavalba High School, the Student Representative Council, SRC, has 25 members, the chess club has 20 members, and the yoga club has 33 members. 5 students belong to all 3 groups, while 13 members belong to the SRC and no other club. 4 members of the yoga club are members of the SRC, but not the chess club. While 10 members belong to both the yoga and chess clubs, there are 8 members of the chess club who are members of the SRC. Okay, so the first thing we should do with any of these types of questions is copy and complete the Venn diagram. Okay, so when we complete this Venn diagram, the best thing to do is to fill whatever's in the center, the one that is common to all categories, and whatever's numbered outside, if there is any. So I can see from this particular sentence that 5 students belong to all 3 groups. So I'm going to put that number right here, 5 in the center. Okay, that's the intersection of all 3 circles. Now this doesn't actually help at the moment. They represent the numbers inside each and every circle, and we don't have enough information to actually find out what are these three smaller components. So let's have a look at something else. The next sentence here says 13 members belong to the SRC and no other club. So that means out of the SRC circle, I want the part that doesn't intersect with any of the other circles, which is this part. And that number there is the number 13. Okay, let's have a read the next part. 4 members of the yoga club are members of the SRC, but not the chess club. So let's have a look at the yoga club. So yoga club's here, but they, these 4 members are members of the yoga club, and they are members of the SRC, but not the chess club. So we're looking at the intersection of yoga and SRC, which is this part. But out of this part here, which I'll just outline, these people that they're talking about are not part of the chess club, so not this one here. So that means we're looking at this space, and we're going to put the number 4 there. Then, in the next part, 10 members belong to both yoga and chess clubs. All right. So 10 members belong to both yoga, so this circle, and chess club. So intersection between those two are right here. So this includes both components, this one and this one. They total up to become number 10. So if they total up to become number 10, this number is 10 minus this number, which is 5. That will become 5. Then the last bit says there are 8 members of the chess club who are members of the SRC. Okay, so 8 members of the chess club, yeah, who are members of the SRC, which is this one here. So the intersection between those two circles is that, and that adds up to be 8. So that number there is 8 minus 5, which is 3. Okay, and now we can complete the rest of the circles. So let's try and find out people who do only chess and only yoga. This circle adds up to become 20 members. So if I get 20 minus the numbers inside that circle, I should be able to get 7. Whereas for yoga, if I was to get 33 members subtracted by these 3 numbers, I will get the number 19 who do only yoga. Okay, now that we've done the hard part, we can now answer all the questions. So for part B, how many members belong to the yoga club only? We just found out that is just 19. And it's asking how many and not a probability, so we write 19. How many again? Students belong to the chess club and no others. Okay, so that means the same thing as only the chess club. That's this component of that circle, which is 7. D, find the probability of selecting a student who belongs to exactly 2 clubs. So if it's exactly 2 clubs, it doesn't include these ones because they involve 1 club only. We don't include the one in the middle because that includes all 3 clubs. So it's the one here, here, and here, which are belonging to 2 clubs only. So if we add 3 plus 4 with 5, right? Okay, what is that going to get us? 3 plus 4 plus 5 is going to be 12 out of how many members are there in total? Well, we've got to add up all the numbers in there, okay? Because I don't think in the question it actually says so. So if we add up all the numbers, 13 plus 3 plus 7 plus 5 plus 4 plus 5 plus 19, I get 56. Now if I simplify that, I do get 3 out of 14. Okay, that's my answer. What is the probability of a student belonging to at least 2 clubs? So at least 2 clubs means 2 or 3. We already found out the people who belong to 2 clubs, so we just have to add the one in the center belonging to 3 clubs. That's 5. So if I add another 5 to this number, that would be 17 out of 56. Question F, find the probability of selecting a student who belongs to the yoga club and the SRC, but not the chess club. So, the yoga club is here, and the SRC, which is there. So we're looking at the intersection of these two. That satisfies this sentence, but not the chess club means we don't want the 5 there. So we're looking at just the number 4 out of 56, which is 1 out of 14. Now, if we look at only the people with 1 club, that'll be these 3. So 13, 7, and 19. So if I add it together, that will get 39 out of 56. Part 3, the SRC or the chess club, but not the yoga club. So SRC or the chess club. Now just be aware that it says or, which means that we count everything inside these circles. So it's all of these, okay? Let me just circle that again. Or actually, let me just outline it this way instead, okay? And it doesn't want people from the yoga club. So if it doesn't want people from the yoga club, we have to exclude what's in the bottom circle. So it only includes those numbers on the top, which are 13, 3, and 7, okay? So 13, 3, and 7, they add up to become 23. And that's out of 56, right? And then for our last part, at most 2 clubs. At most 2 clubs means at maximum we have 2 clubs. So they have to belong to either 0 clubs, which is nothing, okay, because there's no one that's not in a club. There's no one outside the circles. Or 1 club or 2 clubs. So that means everybody except the people or whoever it is, the members, who belong to the 3 clubs. So we exclude this one, but we include everything else in the circles because they belong to 1 or 2 clubs. So if we get the number 56 minus the 5, that's 51 out of 56. I hope that helps you.